Okay, this is 7.3, number 29, and we have four parts of this. So this is part A. So we have the region bounded by the curves y equals the square root of x, y equals 2, and x equals 0. So this is y equals the square root of x, good old John Travolta, y equals 2, and x equals 0, so I've outlined that in kind of orange there, so you can see that. And we're going to, first of all, revolve that about the x-axis. So the x-axis is horizontal. Whenever you're revolving horizontal, okay, you're going to be using what we call vertical disk, but we're going to be integrating with respect to x, so that's going to be dx. In this case, there's going to be a little hole there because as we take this region and we revolve it around the x-axis, you see that there's a gap here. So it's going to be like a cylinder, and then we're going to cut out this little bowl there, almost like we're going to cut out a searchlight, it looks like, out of that cylinder. So we're going to use the washer method. This will be a washer method because there is a little gap in it. And the general form for the washer method is the integral. So we're going to go from 0 to 4 because if we look at this curve, this is where it intersects with the line y equals 2. The square root of 4 is 2. And we're already in terms of x. So we want our two radii, the large radius, which is the whole thing, the cylinder, minus the small radius is what's happening is when these little disks generate the searchlight portion. All right, so that's going to be the area of these little disks, and this will be for a cylinder, minus the area pi r squared. Remember, r is a function of x, so I put that in so you remember that, of this cylinder, which is going to get big. All right. Now the radius of this cylinder is just going to be the height of the curve. That's not a problem. And the radius of the this, like I said, this little searchlight will be just the curve y equals the square root of x. So that's always going to give me my height as I move along here. And then this is always going to be 2. So the top curve is the large radius. So it's going to be, and I took out the pi. So I've got the volume equals pi times the integral from 0 to 4 of my top curve, which is my large, the whole cylinder, which is 2 squared. And if you figure that out, that's just going to be the volume of the cylinder, minus the inside portion, which just does change as we go along. That's the square root of x squared, and that's the bottom curve, dx. So that's basically how you set up the washer portion of it. Again, it's like we're taking this whole volume of this cylinder, which is this part, which would be actually 4 pi. And we're going to subtract this, well actually it's 4 pi times 4 because we got this height. So that would be the area times the height. And then we're going to subtract this, which is constantly changing. So we have volume equals the integral from 0 to 4 of 4 minus x. 2 squared is 4. The square root of x squared is x. And then we just take the antiderivative, which is going to be just 4x minus x squared over 2. And again, we're going to take these disks from 0 to 4. And then 4 times 4 is 16. 4 squared is 16 divided by 2 is 8. So just 8 pi. Okay. The B part, we're going to take this same region, but we're going to revolve it about the y-axis. So now the axis of revolution or rotation is going to be vertical, so this is going to be dy. It's going to go around here, so we have to write everything. It's going to be dy, so everything has to be a function of y. And it looks like there's no gap here. We're just going to rotate it around. There's no holes or anything, so it's going to be the disk method. So we have to, again, have everything in terms of y. We have to have the radius as a function of y, so we just take y equals the square root of x squared both sides, so y squared equals x, or x equals y squared. And that's going to be my radius of these disks. It will always be y squared. That will be the x value. So I just substitute that in, so I'm going to take the integral, and I'm going to go from 0 to 2 now in this case, because it's going to be these horizontal disks. Okay, I'm going to go from 0 to 2. So my radius is x, which is going to be y squared. So when I square that, that's going to be y to the fourth. Again, I took out my pi, so I'm going from 0 to 2, y to the fourth dy. Now if I take the antiderivative of that, that's pretty straightforward, just y to the fifth over 5, pi. That's from 0 to 2. And then 2 to the fifth is 32, so I've got 32 over 5 times pi. So that's my answer, 32 fifths pi. Okay, so that's the B part. And now we have the C part. I kind of worked these out ahead of time. And now we're going to rotate this about the line y equals 2. So now my axis is horizontal. So it's going to be with respect to x, kind of like the x-axis. Horizontal line. So it's going to be dx, so everything has to be back in terms of x. And again, there's no gap in here, so this will be the disk method. So I try to indicate that over here. Disk. Now it's a little trickier because since we're not going around the x-axis, we're going we're going over the y equals 2. We're going to have to find the radius of these little disks, these vertical disks. So this radius will always be given by the whole height minus this height gives me that little section, or top curve minus bottom curve gives me the radius there. So the top curve is y equals 2, the bottom curve is the square root of x, so that's going to be my radius. And again, I'm just going to integrate from 0 to 4. From 0 to 4, pi radius squared, radius as a function of x dx. Again, horizontal is dx. I take the pi out, so I've got 0 to 4, and my radius, as I figured out over here, was top curve minus bottom curve, which was 2 minus square root of x squared dx. And then we just square that out. Binomial squared, that's going to be 4. And the square root of x is the same thing as x to the 1/2, so it's going to be 4x to the 1/2, and then plus the square root of x squared, plus the square root of x squared, which is just x. And then I'm ready to take my antiderivatives and evaluate that from 0 to 4. So the antiderivative of 4 is 4x. And then we've got 4x, and then that's going to be x to the 3/2 divided by 3/2 or times 2/3, so that's 2/3 times 4x to 3/2, and plus x squared over 2, and I'm going to evaluate that from 0 to 4. So we substitute in, we get 16. Okay, this is 8/3, and then 4 to the 3/2, I take the square root of 4 is 2, 2 cubed is 8. And then x squared, 4 squared is 16, divided by 2 is 8. 16 plus 8 is 24, 8 times 8 is 64 thirds. And I make these all over 3, so 24 times 3 is 72 over 3, so that's 72 thirds minus 64 thirds is 8 thirds pi. That's your answer. Okay. And the D part, we're going to take this same region, again the same region, so I've outlined it in orange again, all the examples. And we're going to rotate that about the line x equals 4. Now again, that's a vertical line, so that's going to be dy, that's like the y-axis. So everything has got to be in terms of y, so we go back to x equals y squared. And again, we're going to rotate this region about this line. This is what the reflection would look like about the line x equals 4. So again, we're going to use the washer method. So it's going to be from 0 to 2. So we're going vertical from 0 to 2. So we're going to use horizontal discs. And we're going from, actually horizontal washers actually, because this is the washer method, because I'm going to have a gap here. You can see this is like a big cylinder here. Take away this little dome here, which would be a very flat searchlight if you want to think of it like that. It's kind of like the other problem. So it's a big cylinder here. Okay, so that's going to be my big R, my big region, and my little region will be my little radius will refer to the area of the inside region, or the volume, I should say, of the inside region. So we have pi big R squared y as a function of y minus pi little r squared as a function of y. So we take out the pi, and I looked over here and I figured out my big radius was just the right curve minus the left curve, which is 4 minus 0, which is just 4. And my little radius, my inside radius of my inside region, I'm going to subtract from the big one, would be the right curve again minus the left curve. But in this case, the left curve is x equals y squared, so 4 minus y squared. So that's right curve minus the left curve. And again, that's going to give me this radius here. Whatever this is, it's going to be the whole thing minus that gives me that. And again, that's intuitive, or right curve minus left curve. So that's going to be my little r, so I just substitute those in. I take out the pi, so my big R squared is 4 squared, and my little r squared is 4 minus y squared squared. And the rest is mechanics. 4 squared is 16, minus, and then this is a binomial, 4 minus 8y squared plus y to the fourth, all that dy, then 16 minus 16 cancel. Negative times a negative is a positive 8y squared, and a negative times a positive is negative y to the fourth. So I'm ready to take my antiderivatives. So I have pi, and that's going to be 8y to the third over 3, minus y to the fifth over 5, evaluated from 0 to 2. And 2 cubed is 8. 8 times 8 is 64, so I've got 64 thirds. 2 to the fifth is 32 fifths. My common denominator is 15, so this ends up being top and bottom, multiply the top and the bottom by 5, I get 320 over 15, minus top and the bottom by 396 over 15. If I subtract, I end up with 224 pi over 15. So there you go.